Okay, so now we will be reviewing the chapter 9 of CCNA1, the transport layer. Let's see. So this is my first time reading this chapter. So the same as with chapter 10 and 11. So last semester I think I just read up to chapter 6 or chapter 7. Not all. So this is my first time, so I admit that this is my first time reading this chapter 9. So chapter 10, so I didn't right now, so I didn't read this yet, and also chapter 11. Okay, so okay, we'll start now. So transport layer. Okay, so in transport layer, so it ensures that packets are delivered to the destination host. So they ensure that in the transport layer. Okay, let's see role of the transport layer. So it's responsible for establishing a temporary communication session between two applications and delivering data between them. Okay, so an application generates data that is sent from an application, a source host, an application, a destination host. Okay, so the data from the application layer, so it goes to transport layer for encapsulation. Okay, transport layer moves data between applications on devices in the network. Okay. Okay, this is without regard to the destination host type of media over which the data must travel, the path taken by the data, congestion on link, or the size of the network. So I think that is the work for the other layers, the lower layers. Okay. Transport layer responsibilities. So we have tracking individual conversations. Okay, let's see. Okay, tracks each individual conversation flowing between a source application and destination application separately. Okay, let's see. Okay. Because for in figure 1, a host may have multiple applications that are communicating across the network simultaneously. Okay, so track individual conversations. So the host here can let's see. Okay, can track and maintain these multiple conversations. Okay, because a host may have multiple applications that are communicating across the network simultaneously. Okay, so they're using different applications. So in transport layer, they can track it individually. Next is segmenting data and resembling segments. Okay, so data must be segmented. Okay, because we can't deliver the data, a large data, because it can result to some errors. No errors. Just for target limitation of trade. Okay, transport layer have services that segment application data into blocks that are on appropriate size. Okay, so the data that the application data must be segmented into smaller pieces. Okay. Then identifying the applications. So to pass data streams to the proper applications, transport layer must identify the target application. Okay, so the transport layer assigns each application an identifier called a port number. So even though they travel in a single link, so they are identified by the transport layer. Conversation multiplexing. So on conversation multiplexing, like this one. So okay, what is conversation multiplexing? Okay, so the segmented data Okay, so the figure shows the segmenting the data into smaller chunks enables many different communications from many different users to be interleaved on the same network. Okay, so multiplex. So they can travel on the same network, but they are identified by the transport layer. Okay, so error checking. Okay, segmentation allows conversation multiplexing. Multiple applications can use the network at the same time. Okay, so if the data is not segmented, so the data from other paths or links will be paused. Okay, so they will make wait for their turn. Okay. But for segmenting, so they can multiplex. Okay, they can use the network. Transport layer reliability. Okay. Okay, we have is also responsible. Transport layer is also responsible for managing reliability requirements of a conversation. So different applications have different transport reliability requirements. So some applications here, for example, we have the FTP, HTTP, and SMTP. So use the TCP, no. And then for like the DNS and FTP, so this UDP. So on the later will be identifying what is the TCP and UDP. But for TCP is considered a reliable, full-featured transport layer protocol. So it ensures that all data arrives at the destination. So while UDP is a transport layer protocol that does not provide reliability, so it therefore has fewer fields that is faster than TCP. Okay. So TCP, okay. So it can be compared to a shipping order that is broken up to several packages. A customer can check online to see the order of the delivery. So we have a reliable and connection-oriented TCP. Okay, we have the TCP. There are three basic operations: reliability, we have numbering, tracking, data segments, acknowledgement, and retransmitting and acknowledge data after a certain period. Okay, so we allow retransmit of data. Okay, let's see. So here the data from the host, sending host. Okay, so it sends out the 3 out of 6 segments to the server. Okay, now the server acknowledges the first 3 segments received, and now the host sends the next 3 segments. I think it will also be okay, so no segments are received, so the transport layer will retransmit the data. Okay. Then an acknowledgement also. So acknowledgement for every transmission of data. But for UDP, so they just since there's no acknowledgement or retransmission. Let's see. It does not care if there's a missing message or what. There's no acknowledgement from the destination host if they receive the data. Okay. So the right transport layer protocol for the right application. Okay, so different applications have different protocol to use, transport layer protocol to use. So here are some of the in the figure we have. Let's see. Okay, for UDP we have IP telephony and streaming live video. So they use UDP. So required protocol properties. So UDP is fast, low overhead, does not require acknowledgement, does not resend lost data, and delivers data as it arrives. For TCP, so it requires protocol properties. So it's okay. So required protocol properties. So we have reliable. So TCP is acknowledges data, presents lost data, and delivers data in sequence order. So the most common applications that use TCP is SMTP or POP3 email or POP email, and then the HTTP. Dcp features, let's see. Okay, so to understand, okay, TCP services. Okay, so instant messaging, multiple web pages, and email. So these applications use TCP services. Okay, so TCP services, so it serves establishing a session, so it ensures the application is ready to receive data. Same order delivery, so it's for the reassemble of the data on the proper order of the data. Reliable delivery, so all the lost segments are resent. And then flow control, so ensures that the receiver is able to process the data received. TCP header. Okay, so it has 20 bytes of overhead. So I have the source port, destination port, the sequence number. It's a 32-bit. Okay, the header length. That's it. So source port and destination port used to identify the application. Sequence number is so used for data assembly purposes. Its sequence number is generated randomly. So acknowledge number, so indicates data has been received and the next byte expected from the source. The header length, where is the header length? So it's the 4-bit. Okay, it just indicates the length of TCP segment header. Reserved. Okay, it's reserved for feature. Control bits. So include bits, codes, or flags, so which indicate the purpose of function of TCP segment. Okay, we have the flags. For example, we have the fin, so finish for terminating the session, the acknowledgement, the sync for synchronizing. Okay, window size, so indicates the number of bytes that can be accepted at one time. Okay, so we will be discussing this later. This window size. Checksum for error handling. Urgent, so indicates if data is urgent. So UDP features, so it is the best effort transport protocol. So data is reconstructed in the order that is received. Okay, so there is no reordering, it's just reassembling the time where it when it received. Then any segments lost are not resent. Okay, so no session establishment. So it's connectionless. Does not inform the sender about resource availability. We have the UDP there. So as you can see, we have smaller bytes or smaller overhead, little overhead from UDP. Okay, so we have the source port and destination port, the length and checksum. So it's for error handling. Okay, one of the most important requirements for okay, because UDP is most commonly used for video calls or voice call. So because this application can tolerate some data loss with minimal or no noticeable effect. So even though there are missing segments, so it's just a little delay. So it's commonly it's not noticeable. Okay. So it's perfectly suited to UDP. multiple separate conversations. So transport layer must be able to separate and manage multiple communications with different transport requirements needs. Okay, so this is the use of port numbers to identify the applications. So you have the electronic mail, so you have the port 110, the HTML page, so they uses the port 80. The Ethernet chat, so 531. Okay, so we have the port numbers, source port, and destination port. So source port is dynamically generated by the sending device to identify the conversation between two devices. So source port and destination port, so somehow the same with the source and destination address, but it uses the port numbers as the source and destination port. So for the destination port, so it tells the destination server what service is being requested. Okay. So for example, when client specifies port 80 in the destination port, the server that receives the message knows that web services are being requested. Okay, so source port. So we have range for port numbers. So for source port is, I think they use the dynamic port numbers. Socket pairs. So socket pairs is so it consists of source port and consists of as a combination of source IP address and source port number, or destination IP address and destination port number. So an example is this one. So 192.168.1.5. So source and let's see, 1099. Okay, they use this. So for web connection, so source IP and then the source port, and then the destination port and destination IP and destination port. So for us to distinguish themselves, sockets enable multiple processes running on a client to distinguish themselves from each other. So socket pairs are used because IPs are unique. It's a unique address. Okay, so this is what I am saying. Support number groups, we have well-known ports. So these are the reserved for services and applications. So we have, for example, we have the HTTP. We have the port 80 for HTTP. Registered ports. So it is assigned. These are port numbers assigned by the IANA to requesting entity to use with specific processes or applications. So we also have the dynamic or private ports. So these are used most commonly for source port by the client. So figure 2. Okay, so well-known ports numbers of the FTP. So F20 and 21, SSH 32. So those are well-known ports. Nets.command. So what is this nets.command? So it's to list the protocols in use, the local address. So the nets.command is entered in a command prompt. So it outputs protocols in use, the address. So I think this is the port number, HTTP foreign address, also the HTTP address. Compare TCP and UDP characteristics. So it is connectionless, less overhead, fast transmission, no acknowledgement, no order delivery. TCP server process. Okay. So client sending TCP request. So the source port is source port of this client. The client's here. The destination port is, so it identifies the services the client wants to access or use. So for example, we have the destination port 80, so they use the HTTP. Server will identify that, and also for port number 25, so for SMTP. Request destination ports. Okay, so use well-known ports as the destination port, and then use dynamic port numbers as the source port. So request source ports. So response destination ports. Now for the response for the server, the server will use the source port from the client as the destination port, and then the destination port of the client will use as the source port. So just I think it is the reply. It's the same with IP, but much more on services. So they're talking about services. Tcp Connection Establishment. Okay, so first one, so they need to synchronize. Okay. Step 1 is initiating client request, client to server communication session with the server. Okay. So the client will initiate CYN, so it's a synchronized request to be. Then it will receive the SYN, and receive will send synchronized. Then now for the server to client, okay, now sends a server to client, and then also an acknowledgement from PCB. Then now for establishment, so the initiating client acknowledges the server to client communication session. Okay, now for the TCP session termination, so the PCA sends a fin or finished. So the PCA wants here to terminate the connection. Then it was received by PCB, sends acknowledgement, and received by PCA. Also, the PCB will send a terminating message or finished. Then it will be acknowledged by PCA, and then will be received, and then it will send an acknowledgement that connection will be terminated. Termination ended. Session terminated. So TCP three-way handshake analysis. Okay. So the first one is it establishes that the destination device is present in the network. Now verifies that the destination device is an active service and is accepting requests of the destination port number that the initiating client intends to use. So it informs also the destination device that the source client intends to establish a communication session on that port number. So in this example we have, okay, flag examples. You have URG, the acknowledgement, PSH, post function, so reset. Okay, so this is for resetting the connection. Synchronize sequence numbers and fin. So it finished, no more data from sender. Another activity, so send, check, send fin, it will acknowledge by the PCB, send finish, then will receive and acknowledge. Check. TCP reliability order delivery. Okay, so So different segments may take different routes. Okay, because data is segmented. So having taken different routes, two destination segments are right out of order. So as you can see here, we have unordered segments. So TCP reorders the segments to original order. So that is the work of TCP. Order delivery. Sequence numbers and acknowledgement. Okay, so they use this for so ensuring that each segment reaches its destination. Okay, so I think they use so as you can see, we have I am sending 10 bytes. I received 10 bytes starting with byte. Okay, so they use the window size. Data loss and retransmissions. Okay, so for the for handling data loss and retransmission, so TCP uses some of algorithms and mechanisms to retransmit segments. So I think one solution is a timer. So if it does not receive any acknowledgement in a given time, so it will retransmit the message. Okay. And also, so they what is this? They reduce the number of bytes in sending, because maybe there is a network congestion happening on the Window size and acknowledgements. Okay. So window size it determines the number of bytes that can be sent before expecting an acknowledgement. Okay. So even though it's like they will send a sequence of segments without expecting any acknowledgement. So it will just send acknowledgement after that sequence. So let's see, as acknowledgement number is the number of next expected byte. So let's see, so window size is 10,000 bytes, and then the maximum segment size is 1,460. Window size, what is the window size? Send window 10,000, so it sends 1,460 bytes and receive 1,160 bytes. Okay. Then it will also send another 1,460 bytes, and it will be acknowledged by the PCB. Receive acknowledgement. So TCP flow control, congestion avoidance. Okay. So for TCP congestion control, so the destination host that, because the PCA does not received or is not receiving any acknowledgement, now the PCA will reduce the number of bytes that it sends for getting acknowledgement. So acknowledgement numbers are for the next expected byte and not for a segment. Segment numbers are simplified for illustration purposes. Okay. So acknowledge segment 2. So this it expects the next segment. So because it does not receive any, for example, segment 2. So we need to acknowledge that it is the next expected byte. Low overhead versus reliability. Okay, so this is for UDP. So UDP does not establish a connection before sending data. So UDP provides the overhead data transport because a smaller datagram header, no network management traffic. Okay, so it is connectionless. So unlike for TCP, it is connection oriented. And also some sequencing for TCP and flow control. So UDP is not does not provide that functions. So, but does not mean that applications that use UDP are always unreliable, or does it mean that UDP is inferior protocol? So, it depends on the application. UDP datagram assembly. So I think they did not. Okay, so they don't reorder the data. So are not reordered. Those datagrams are not resent. So it just forwards it to the application the way it the order it was received. So it just received to the application. So it is same with the it's the same with TCP. So UDP also uses port numbers. Port numbers. UDP client processes. Let's see. Okay, so they use UDP request. Okay. So client here uses requesting for an applications. So UDP applications. So specifically. So they use the source port number, so it was dynamically generated, and destination port, and for the application. So application they want to use. So obviously the UDP obviously they will be using UDP applications, not TCP. I think this is the same with the earlier with TCP. So they use the source port, destination port for well-known port numbers, and then random port numbers as the source port numbers. Just will the source port and destination port. So after the server received it, so it will just reverse. So now the source port number is the service provided by the server. Then the destination port is the source port number of the client. Using Wireshark. Applications that use TCP. So we have the HTTP for web browsing, FTP for file transferring, SMTP for email, and Telnet. Okay, so for connection. Then applications that use the UDP, so most commonly is for the VoIP, and then for what is IPTV. So I think this is for video streaming, SMP for DNS, and DCP. So there are three types of applications that best suited for UDP. We have live video and multimedia applications. So for video calls and voice calls, simple request and reply applications, for DNS and DCP, and applications that handle reliability themselves. Where flow control, error detection is not required. So but DNS and SNMP, so they can use UDP and TCP, both UDP and TCP. TCP, we have HTTP, Telnet, DCP is UDP, SNMP is both, SMTP is email, DNS is for both, IP, TP, and FTP. So I think that's it for chapter 9, transport layer. So we have learned the UDP and TCP. So TCP is connection oriented, while the UDP is connectionless and best effort delivery. So TCP also acknowledges segments, also transmit data or segments. So they also use port numbers to uniquely identify the services the clients want to use. So that's it.